Good news, everybody. I have noticed an uptick in fan showdown submissions.
This guy's called Major Hardware. I think he actually might be an Air Force major. He runs a YouTube channel where he tests people's 3D printed fan designs, like axial electronics cooling fans. And I think it's really cool. He has like a leaderboard going on. I thought this was a really great idea, and it's only something you can do today with all 3D printing and CAD stuff. So I wanted to give this a try. So I made a parametric model in Fusion 360 that works on 4 parameters. The first is root angle of attack, which is pretty self-explanatory. The root of the blade's direction or angle relative to the direction of motion. And then tip angle of attack, which is the same idea for the tip of the blade. And then I also looked at sweep angle. So this is how angled from the line that goes perpendicular from the root away from the hub the tip is. And you can see that there. And then, of course, I looked at what seemed to be the most important of all of these, which was the number of blades. So I tested anywhere from like 6 to, I want to say 15 blades in some of these designs. One thing that I couldn't do, though, was parameterize the airfoil profiles for the blades. So I ended up choosing, and the reason I couldn't do that is because like they use like I use like a script to import the splines for different NACA airfoils. So I ended up choosing like a thicker kind of 25% camber reflexed airfoil for the root and like a thinner version of that for the tip. You can see how the importing of the DAT file works here for getting the airfoil profiles in Fusion 360. And yeah, so I wanted to test these out using CFD kind of as a way to get myself more familiar with CFD software. And I used Fluid 3DX, which is on GitHub for free. So first I started with no sweep angle, shallow AOAs, and few number of blades. And I mean, this looks okay, but as you increase the sweep angle and number of blades, you get a better result, like less turbulence at the wingtips, which makes sense. And then this one was one of my best. It had 12 blades and like pretty steep angles of attack and 30% sweep. And it's like you get a lot of airflow, but not so much. It's pretty turbulent. So I tried adding like kind of ellipsoid blade tips to try to get like inspired by the Spitfire Warbird. And that like seemed to not get as much as I wanted out of it because I was delaminating still. So I added these ridges, or I added one ridge that goes down the length of the blade, kind of as an attempt to like push back the boundary of delamination. You can see them side by side here. It's kind of hard to tell, but there is sort of, it seems to be at least, that there's sort of a reduction in that delamination. Maybe not. I don't know. Maybe it's worse. I don't know. So then I added more ridges, and you see here like it's not obvious that the ridges are like improving things. So I was kind of like stuck trying to figure out what to do next. I'd heard that winglets were important, and like they're on all commercial aircraft now. And here's a comparison of like no ridges, one ridge, and multiple ridges from a sagittal view. You can see that like there's no real difference in flow. Anyway, I'm going to keep working on this, see if I can come up with a better solution that maximizes static pressure within the dimensions that are required for the fan showdown submission. Thanks for watching.